Hi, pre-calculus students. We are going to talk about 6.3 and 6.4. So we started that Desmos activity in class today, and we didn't really get to finish bringing it all together. So I wanted to just kind of summarize. So you can see here, this is the 6.3. This is like the formal definition of period. I don't know that you necessarily need to have that memorized. It just says if for some real number, that's the Greek letter alpha, f of x plus alpha equals f of x. It just means the y values stay the same over a certain interval. Again, we don't really need to worry about that so much. Okay, these are the examples you did in the Jamboard. Right here is our graph from the cosine that you transferred from Desmos. Okay, make sure you take a look at what it's saying about domain and range and all of that. This x-intercept, that's just for your information. You don't necessarily need to know that, like memorized or anything. Okay, and then at the top, this is page 6. Okay, there's our sine graph. Again, here's domain, range, max, min. Y-intercept and the x-intercepts are pi, multiples of pi, so 1 pi, 2 pi, 0 pi, and so on. Tangent, we will actually come back to later on, so don't worry about that for now. Okay, so I want to look at example 2 and 3 just quickly. So it says find the sine of 3 pi by referring to the graph of the sine function. So if we wanted to do that, we could look at the graph of our sine and think, at 3 pi, what do we think the y value would be when the angle is 3 pi? So if we were to imagine this graph continued and then it would come down, what would be happening at 3 pi? So you might notice that it's hitting the x-axis at pi, at 2 pi, and then it would happen again at 3 pi. So we would say the value of the sine of 3 pi is 0, and we can get that from the graph. You could also figure that out from the unit circle. Right? You could say, okay, 3 pi means, okay, well, here's 2 pi, and then I go 1 more pi to get to 3 pi, and the sine is the y value, it's 0. You can get that more than one way. All right, and so then the next one says find the value of theta for which the sine of theta equals -1 is true. So we want to give the angle or angles for which the y value or the sine or the y value is -1. Okay, so again, I could look at my graph and I see I have y values of -1 happening here and also here. But they're going to keep happening, right? Like, because this graph is going to come down and go up and come down and go up. And same thing this way. It's going to keep happening over and over and over again. And we could also see that if we thought about our unit circle, the sine or y value is -1 at 3 pi over 2, but also all the coterminal angles going forward and backwards. And so the way we can name that is because it repeats. We could start with either one of these angle measures at which the y value is -1, so like 3 pi over 2, and then think how often is that going to repeat? Well, the distance, the horizontal distance from here to here is 1, 2, 3, 4, 5, 6, 7, 8 units in between. And 8 units on our scale, 1, 2, 3, 4, 5, 6, 7, 8, is equivalent to 2 pi. So every 2 pi, we're going to get a y value of -1. So the way we're going to write that is we're going to write 3 pi over 2, because that was like the first time I saw it happen on the positive side, plus it's going to happen every 2 pi. And to say that it's going to happen multiples of 2 pi, we're going to write 2 pi n, where n is an integer. Sort of like when we were naming coterminal angles, it would say name all coterminal angles, and we would add like 360n or 2 pi n. It's that same idea. Okay, we're not going to worry about examples 4 and 5 for now. Okay, so now I'm moving on to section 4. And this first part was sort of an exploration. We didn't do this, we did a Desmos activity instead, but to look and see what happens when I put numbers in front of the sine or the cosine, how it changes the graph. And what we saw in the Desmos activity is that this number in front changes what we call the amplitude. It changes like the height. So from that middle line, how far up and down you're going. So 5 up, 5 down. So we'd say the amplitude is 5, or this one, the amplitude is 1/2. So our definition of amplitude is going to be half the distance between the maximum and minimum. right? You could even write 1/2 of the maximum minus the minimum. And we're going to use the letter A to represent that. And remember, it's the absolute value of A because it's the distance. Okay, so then we also were getting into period and noticing that the number kind of multiplied inside. We were noticing that in our Desmos activity, that changed the period, so the horizontal length of our cycle. So the period for a sine or cosine function is always going to be 2 pi for the parent function. The period is 2 pi. But if we wanted to find it for anything when we're multiplying, it's going to be 2 pi divided by our b value. So if our equation is the form y equals a times sine or cosine of b times theta, this b value that's being multiplied by the angle, we're going to do 2 pi divided by that number. So 2 pi is the period of our parent function, and then divide by b if we have a multiplier. The frequency is just the reciprocal of the period. That will come up sometimes in problems. We won't do a ton with it. I think more when you get into science, you might talk about frequency. All right, so then determine the amplitude and period of each function, of each equation down here. So if you are thinking of these equations in this form that we have up here, right, this y equals, this could be a times either the sine or the cosine of b theta. Remember, the absolute value of a is our amplitude, and doing 2 pi divided by b gives us our period. So go ahead and pause the video and see if you can figure out for each of these equations, what is the amplitude and what is the period. Okay, so amplitude comes from our a value, and it's the number in front. That tells us, so for this one, I would be graphing a sine, and then I'd go a quarter up and a quarter down. That would be where my max and min is, or this would be up, down 3 or 5 or 1/2. Okay, so those are pretty easy to pick out. Okay, for period, it's 2 pi divided by b. So in this case, the b is the number being multiplied. Okay, that one's easy enough to see 2, and this one's easy enough to see 3. But then here you'd have to think of this as 1/2 is being multiplied by your x, and then here pi over 4. Okay, those are my b values. And so now to get my period, I need to do 2 pi divided. So I do 2 pi divided by 2, so that means my period is pi. So instead of it taking 2 pi units horizontally to finish one cycle, it's compressed horizontally. It only takes 1 pi. Okay, this one would be 2 pi divided by, well, this is like x. It's like having 1/2 times x. So my b is 1/2. So 2 pi divided by 1/2. So that'd be 2 pi times 2 over 1, or my period is 4 pi. So now instead of my period being 2 pi, it's double that. It's 4 pi. Okay, this one would be 2 pi divided by, this is like having pi over 4 times x, so divided by pi over 4. So this is 2 pi times pi over 4. Well, this period actually ends up just being 8, which graphing-wise would be great. You don't have to have pi's on your scale. All right, and then this last one, it would be 2 pi divided by my b value, which is 3. That doesn't reduce, so it's just 2 pi over 3. Okay, so now let's get into a couple of examples where you are actually going to graph something. So, and that's what some of you were getting to in that Desmos activity, is where you were actually starting to practice saying, okay, looking at this equation, what's my amplitude, what's my period? Now let's get that onto paper. Okay, so this is a cosine. If I compare this to y equals a cosine b theta, in place of my a, it's like there's just a 1. And then if I want to rewrite this so I could really see the b value, think of this as 1/4 theta. So if my a value is 1, that's my amplitude. So that means my max and min are 1 and -1. Okay, here my period, I would do 2 pi divided by b, which is 1/4. So that's 2 pi times 4, because you multiply by the reciprocal, which is 8 pi. So that means that when I go to graph my cosine, I'm graphing a cosine. Okay, So from our notes, we know that a cosine parent function starts up here at 1 on the y-axis, and it takes 2 pi units normally to complete one cycle. This is normally 2 pi, and then it has this minute pi, and then a half pi, right, and 3 pi over 2. This is 1, and this is -1. Okay, that's my normal cosine. But here's the thing. Now my period is 8 pi. So my scale is totally changed. Okay, so now the idea is if I know my period is 8 pi, I'm going to make my end point here, make sure it ends at 8 pi. Okay, I know it hits this minimum halfway between these. So this I know has to be at 4 pi. It hits this x-intercept halfway between here and here. This has to be 2 pi. This has to be 6 pi. Okay, again, the way I know this, the way I know that's what that looks like is by going back to page 5. There's my parent cosine function, right? And I'm just going to focus in on one cycle, right? One cycle from 0 to 2 pi normally. But now with this one, it's from 0 to 8 pi. So when I set up my scale, like these graphs here go out 9 units. Well, I might as well just make this 8 pi here. And then this is 4 pi, and then my 2 pi, and here's my 6 pi. I usually figure out the end in the middle and then split from there. Okay, my amplitude goes up 1 and down 1 for my max and min. Now I could put my 1 here and here, but then it gets kind of squished. So I'm just going to have them up further just so that it's not so squished. And then what I'm going to do is kind of take my sketch here and transfer it onto my grid. So I see at 1, I have a point on my y-axis, so I'm going to plot that point. I noted here at 2 pi, I hit the x-axis, so I'm going to put a point at 2 pi. At 4 pi, I'm hitting my minimum of -1. Okay, at 6 pi, I hit my x-axis again, and then at 8 pi, I'm back up at 1. Okay, and then I'm going to draw my curve through. Now cosine, because these do keep going, right, it would normally cycle back down, right, and this would come down and so on. I am fine, though, with you just drawing one cycle, one period of it, but do include the arrows and just make sure that you don't have it like, it doesn't keep going up like that, like a parabola. It does curve back down. So just be careful if you're putting arrows on it. You kind of make your arrows, you like turn and put your arrows. Okay, so that's how we would get these graphs. All right, let's look at part B. So part B, we've got a sine, and it's -2 sine of theta. So a negative, what that's going to do is it's going to take the graph and it's going to flip it over the x-axis. Just like if you had x squared and you flipped it, it would be -x squared. It's the same idea. So for this one, if I wanted to think of it in the general form, okay, so I have -2 times the sine of my b value is just 1 theta. So my amplitude is the absolute value of a, which is 2. My period would be 2 pi divided by my b value is 1, so just 2 pi. Well, that's kind of nice. My period doesn't change, so I can just put that regular scale that I had on my parent functions. And the difference is going to be 2 things. The amplitude is going to be 2 instead of just 1. And then the other thing is that this negative is going to cause a reflection over the x-axis. So when I do my little sketch, how I did for my cosine, okay, so normally, let's take a look. Normally our sine looks like this. It's like a hill and a valley. All right, but now it's going to flip over. So it's going to be a valley and a hill. Okay, so my parent function would look like this instead. That's got the reflection in there. Okay, my period is 2 pi, so my cycle ends at 2 pi. So this would be at pi. Right, this is halfway. It's almost like you're splitting your graph. It's half into quarters. Okay, so I'm using, I know it's all squished in there, I'm sorry. So I'm using the same scale I did on the parent function. And now if I know my amplitude is 2, that means my maximum is 2 and my minimum is 2. Okay, so when I go to put my scale on here, I'm just going to end at 2 pi. I usually end on that 8th one if I can, because then I'm splitting into quarters. It's easy to split into quarters. So this is a half, or I'm sorry, halfway is pi, and then half of that is a half. These are just, if your period didn't change, it's just from the axes. Okay, my amplitude is 2, so maybe I'll say here's 1 and here's 2. and here's -1, and here's -2. Okay, and now I'm going to just use this little sketch over here to get my graph. So my graph is starting at the origin. At pi/2, I'm down to my minimum, which is -2. At pi, I'm at the x-axis again. Okay, at 3pi/2, I'm up to my maximum of 2, which is here. And then at 2pi, I'm back to the x-axis. And so there I have my reflected sine. And now this one would keep going too, but like I said, I'm okay with you just doing the one cycle for now. All right, so one more we have here, 5 cosine of 2 theta. So my A value is 5, which means my amplitude is 5, and my period is 2 pi divided by B, which is this 2. So my period is pi. So this has gotten squished in. So if I keep my scale 2 pi, like that, like 0 to 2 pi, which I can, that means that my cosine is going to be squished in this little space here. Because there's no shifting involved, which we'll get into next time, you could just expand your graph and just say, oh, I'm going to put pi here at the end instead. It's up to you. Okay, so this is what, a cosine. So I kind of like to start with, all right, here's one cycle of the cosine. Okay, it usually ends at pi. So now this halfway would be pi/2, right? Half of a half is a quarter. So this is pi/4. So this is a quarter, a half. Then this is 3 pi/4, and then pi. Now my amplitude is 5, right? So my maximum and are 5 and -5. So when I go to do my scale on this one, I'm going to go by 1 so that I can fit everything on there. Okay, and then I'm going to just use this to get my sketch on there. So at the x is 0, my y value is all the way up here till 5 at the top. At pi/4, whoops, I didn't put my scale on here. Pi/2, pi/4, it's going to be at 0. Okay, at pi/2, I'm down to -5. At 3 pi/2, I'm at 0. And then at pi, I'm up to my maximum again. Okay, and so then I draw, and there it is. Okay, so we will be practicing with this next week in class. I know it's kind of at first seems a little bit confusing with the periods, especially amplitude, not so bad, but the period's kind of confusing. Okay, and then the last example here, now write an equation if I give you information. So if I say write an equation of the sine function, amplitude is 2 and period is pi/2. So my general form would be A times the sine of B theta or Bx, it doesn't matter. Okay, amplitude, that's my A value. Period, well, that's not my B value, right? I get my period by doing, so I know period is 2 pi/B. If my period is pi/2, what must my B have been in the equation so that it would reduce to give me pi/2 for my period? So some of you might look at this and say, oh, well, 2/4 is 1/2, and so B is 4. So you could get it that way and say y equals 2 sine 4 theta. Now, if you're looking at this equation and saying, I don't know how the heck you're getting 4, what you can always do is just do a quick little solve, just cross multiply and say theta times B, right, equals 4, not theta times B, pi times B, equals 4 pi. And then if I solve for B by dividing, I get B is 4. Okay, so that's a way to do it. Sometimes they are trickier than that. And then one other thing to add to this is technically this could be a +2. If the amplitude is 2, the equation could have been a +2 or a -2, right? Because we had that example earlier where it was a negative in front, but the amplitude is still 2. So you could have it be positive or negative. I'm going to put the plus or minus in front. You don't necessarily have to, because if you just write it with the 2, you have written an equation that has an amplitude of 2. Okay, so hopefully this helped kind of bring together everything that was in that Decimos activity from class. And next week, we're going to practice all of this graphing. Okay, so I hope you have a good rest of your day and a good weekend. And my mouse isn't working. Being evil. Okay, so have a good day, everybody.